Hi, I'm Meta Spencer. Today, we have to get caught up on matters having to do with global warming and climate change because for the last 6 weeks or so, everybody has been so distracted by this war in Ukraine that we haven't been paying attention to an even more serious global threat. And that is, of course, climate change. So I have been lucky enough to get my two what do I want to? I was about to call you cosmonauts, but
comrades in arms.
I'll talk about climate and instead of outer space today. And in Ottawa is Paul Beckwith, who's a big specialist on all things having to do with the global climate. And in, I guess, Turin, Italy, I hope, is Peter Wadhams, who is a specialist in the Arctic sea ice matters. And that's always, the news of the day is always which ice shelf is breaking off.
So, of course, the IPCC, Intergovernmental Panel on Climate Change, Working Group 3 report was released just 3 or 4 days ago, earlier this week. And it's a 3,000-page document. And I did do a video summarizing some of the highlights from the summary, the SPM, they call it, Summary for Policymakers. And it's, if you look at, so it in combination with Working Group 1, which is the physical basis, and Working Group 2, which is adaptation and resilience, the total number of pages is about 10,500. So I always like to read these things cover to cover, but of course that takes some time. So, but I find it, is very good, exercise that I push myself to do. So there's that report.
Do you really read those things completely?
Yeah, I do. Well, I try to make it, it might take me 6 years, as long as I've read it before the next one comes out. No, within a few months, I should have most of it done. That's big news that we'll talk about. But I think, as far as Peter and I are concerned, we follow what's happening in the poles extremely closely. Peter is focused on the Arctic, but I'm sure he's up to date on all the Antarctic stuff. So the big news in the last few weeks ago, we set to what, about March 18th, I believe, the Antarctica, both poles had heat waves, and the temperature anomaly in Antarctica was almost 50 degrees Celsius warmer than normal. And in the Arctic, it was 40 degrees Celsius warmer than normal. So if you read American reports, it says 70 for the Antarctica, and that's Fahrenheit. But basically what happened is, I don't know if you remember, we've talked about atmospheric rivers in the past. And last summer fall, we had tremendous flooding in British Columbia because atmospheric rivers that normally would have gone through into California would move further north, and they were coming into British Columbia. And there were 3 or 4 over the space of a week, and it caused massive flooding and catastrophic road damage because the rain fell on mountainous and hilly terrain and caused massive landslides, which took out roads, et cetera, et cetera. And then and I commented at that point, I said, wait till what happens, wait and see if these atmospheric rivers continue to move further north and go right into the Arctic, and also continue to move further south in the southern hemisphere and go into Antarctica.
When a river goes in a certain direction, so what you're suggesting is these rivers flow north?
These are rivers in the atmosphere.
Yeah, but even
these are the jet streams. Yeah, the jet stream is very wavy and broken and is going further and further to higher latitudes. And when it carries tremendous amounts of moisture, derived mostly from evaporation over the ocean, it carries this water vapor with it, and it can carry the water vapor directly up into the Arctic and also back into Antarctica. Now, the water vapor, when it condenses into droplets, it releases the heat. So it maintains the high temperatures in those polar regions. So this is exactly what has just happened in both the Arctic and Antarctica. And in the southern hemisphere, I talked about BC. in the northern hemisphere where these atmospheric rivers were. Well, atmospheric rivers are continuing to hit Australia at the moment. They've, parts of Australia have been getting excessive rain. Like Sydney is under flood warnings right now, as is Brisbane. So the atmospheric rivers are carrying. They're 1 to 3 kilometers high in altitude, and they carry tremendous amounts of water. So the atmospheric river that hit Brisbane, Australia recently was estimated to be carrying more water, 16 times more water than is occupying or filling Sydney Harbor. So we're talking massive amounts of water being carried to certain regions, with the jet stream. What happens is it moves, it's being carried northward, and then it hits a blocked region or a high pressure region. So then the water, it has to go do something, and the water is typically dumped out when at the intersection with those high pressure regions. So what it means is,
sorry, but I'm trying to visualize whether this is something anybody could detect from the ground. Are they like clouds? Do they look like clouds?
They're easy to detect from satellite. Okay, so you can go on. I just did a video last night, which I released, and I show you how to use online tools to see these things. So it's basically, you can go to the website called Climate Reanalyzer, and you can look at the daily picture, or you can click on a picture, you can click on a link that allows you to look at temperature or look at pressure, or look at the amount of water vapor in the atmosphere, for example, the total precipitable water or the cloud water. You can also go to Earth Null School, which is another very good website where you can track the jet streams and you can track the water.
Earth Null School.
Earth Null School, NULLSCHOOL, Earth Null School. You can Google that site. You can look at the Australian floods, get the dates, the week that it's occurring on, and then use these Climate Reanalyzer and Earth Null School to be your own climatologist.
Yeah, they don't look like clouds. Is that it? We can't see them with
No, it's water vapor, which is invisible. Okay. We can see some of the water vapor is condensing into droplets and for clouds, and we can see those. So yes, so you can see those. You're talking about whether you can see them from the ground. It's the scale is much larger. These atmospheric rivers, they're essentially like rivers that are maybe tens of miles across, tens of kilometers across, and thousands of kilometers long. Mm-hmm. They're like fingers in the atmosphere. So the models, Peter can talk to this more, but the glaciologists that say, okay, Greenland's going to take hundreds of years to possibly melt. East Antarctica is solid, likely not to happen. West Antarctic, yeah, it'll also take hundreds of years, centuries, or even thousands of years. Well, I say that with these atmospheric rivers, going into the Arctic and Antarctic, we're talking that they slaughter the ice. We're getting rain and above zero temperatures on the ice, and it just cuts into it. And so the models on sea level rise, throw those out the window. All the models, this is happening, and climatologists have not incorporated it in the models. They didn't even think it would ever happen. People that spend their lifetime studying Antarctica say they never thought they would ever see what has happened in the last month in Antarctica. 2
reports of Intergovernmental Panel on Climate Change come out very close together. The last the Working Group 3 was this week, and the preceding one was not long ago, a couple of weeks ago. This is really weird for the Intergovernmental Panel on Climate Change, which is notoriously complacent and slack in its methods of operation, in that the mental approach of the IPCC is that everything happens rather slowly and follows kind of nice linear changes that allow us n years to prepare for them, or to worry about them. So it's always linear processes that we don't have to worry about for a certain number of years, and then we'll have to worry. But of course, now it's clearly not linear. These are processes which are accelerating very rapidly, and they're happening now. So IPCC, which has changed completely, it's become the sort of organisation that we all knew about or were part of, which is saying, look, this is really incredibly dangerous now, and we have to take action now. So I've just been reading the life of Winston Churchill, and the IPCC used to be like Britain was in the 1930s. That is, not thinking there was a threat to anything, and we had plenty of time to sort of pontificate on it, and then we might do something. But suddenly, this is now like 1940. The disaster is upon us, and we've got to do something. So IPCC's change of heart is quite significant. Then the big effects which have been happening this last week that are really significant are these large temperature anomalies in the Arctic and Antarctic occurring simultaneously. Now we've had big positive temperature anomalies in the Arctic or the Antarctic, but not in both at the same time.
Yes, it almost sounds like an impossibility, isn't it? Because the two poles are supposed to be working in opposite, or taking turns being hot, but they can't both be hot at once, and they are.
Yeah, well, what's interesting is it's happening, this is called the shoulder season, if you like, right? Because we're going into spring, in summer, and in Antarctica, they're going into fall and winter. So the shoulder seasons are basically the fall and the spring. And that's when there's the sharpest transitions or change because of the orbit of the Earth, et cetera, the seasonal change. And this is a time of year where both poles are undergoing massive change to their particular season. So if it's going to happen, it's going to happen in this shoulder season.
Okay.
Well, I lived through a previous extreme positive temperature anomaly, but this, it wasn't anything like this one. This was in 2016. I'd been on a research cruise in the Arctic with a icebreaker, the Sikiliak, and we'd been tracing the sea ice forming in autumn. That's October, November, and it was growing back from its summer minimum, and we were tracking it and measuring the pancakes forming and so on. And this all looked very, very interesting. And so one of the things that struck us was it wasn't advancing in the way that it normally did. After the minimum, you have the freezing starts and the ice edge moves forward towards the Bering Strait, then through the Bering Strait and into the Bering Sea. And here it was stuck still in the Beaufort Sea, and it wasn't advancing. And so when you looked at that, it was because there was a huge heat reservoir in the Arctic Ocean that was due to the fact that the summer had been very, very warm, really seemingly unnaturally warm, but now just typically warm. And all that heat actually was upwelling as the ice was trying to form and advance. So the ice would form, it would advance a little way, and then suddenly there'd be a wind change. The warm water would upwell from underneath. The ice would disappear again. So we were living through for about 6 weeks an advance and retreat of the ice edge where the net advance wasn't there. And then later, when the ice should have been pretty well covering the whole Arctic basin, it was still lying a long way back. So the charts would show a massive temperature anomaly of about 30 degrees, something like we've had this week. But the anomaly was not that there was there was actual heat there. It was because the sea ice hadn't advanced to where it should have got. So relative to the seasonal temperatures, air temperatures that should have existed, the temperatures were much higher because the ice wasn't there. And so
yes, the ice is a good insulator, right? So, and the seas are if the sea hasn't frozen over, then a lot of heat can come from the ocean and heat the atmosphere above it. But when you have that ice cover, even if it's very, very thin, it starts to cut the heat going up on the surface. And so the anomalies are being measured, a few meters above the surface, presumably. And as Peter says, they're 30, enormous. I mean, the ice has a huge role, whether it's there or not.
Yeah, so,
right?
so we think we understood that, but the problem is it was happening in November and December, while the one we've got now is March, which is much later. In fact, it's April. And then the other absolutely difficult to explain phenomenon is having the same magnitude of anomaly in the Antarctic at exactly the same time. So I haven't seen a plausible explanation for why we should have these two at the same time, or both extremely large anomalies. I can understand the Arctic one, although it's happening late relative to the one I kind of lived through, but I can't understand why we should be having the Antarctic one as well. I think that needs a lot of study, but it's frightening that you should have two 30-degree plus temperature anomalies at both poles at the same time. That's something that would really frighten most climate scientists.
Well, now, am I right that the real risk comes from having it rain in the Arctic when it shouldn't, and that this and the Antarctic, that it melts the ice in a way that hadn't been accounted or expected?
Exactly. Yeah. I mean, the in Antarctica, it was the 50 degrees Celsius. It would normally be minus 50 or minus 60 degrees Celsius in elevated regions on the ice cap, like Vostok, things that are not too far from the South Pole, and they're like quite high elevations, 3,000 meters plus. So the fact that 50-degree temperature rise brought it from minus 50 or minus 60 Celsius to minus 10 Celsius. Okay, so it was still below zero in that case, but it was very, very, it was unbelievably high temperature anomaly. Whereas in the Arctic, that 40-degree temperature rise brought it above the freezing point. So we're getting lots of more rain on snow, rain on ice events in the Arctic is one thing. And in Antarctica, we're getting these events not right on the coldest peak, highest elevation parts yet, but we're getting them on the Antarctica Peninsula, which is, higher temperatures to begin with. So the anomaly of 50 or 40 does carry it above zero, and also along other coastal regions of Antarctica. And coinciding with the Antarctic heat wave, we had a massive glacier that calved. Okay, a massive glacier just split up and broke into chunks in Antarctica, in East Antarctica. So this is the most significant thing, I think, that East Antarctica, which has the bulk of the ice, right? If we lose Greenland, we're talking 7 meters rise of sea level, all of Greenland melting. If we lose West Antarctica, which is actually sitting on bedrock that is well below sea level, so it can be melted quickly by warmer ocean temperatures, then that's about another 5 meters of sea level rise. And then the rest of it, is in, there's also a mountain glacier causing sea level rise, right? The melt of that. There's also the thermal expansion of the water heating expands. But the bulk of the sea level rise would be from East Antarctica, and it's expected that that's pretty solid, should last thousands of years. But when we start getting rain on the fringes, then the game has to be completely rewritten. Like we're going to get massive sea level rise if we get more and more of these heating events at the poles. That's the way it is.
Okay.
The frightening thing about the sea level, of course, is that you can't do anything about it. I mean, in theory, if you pour in enough money and do dramatic things with air capture systems and so on, you can do something about air temperatures. We can hopefully try to control them, or we can do things with marine clouds, do marine cloud brightening, but we can't do anything really about sea level, because it's the main ice sheets of Greenland and Antarctica that are melting, and changes in air temperature, obviously a warming can accelerate that rate of loss, but not that much. It's not going to change the sign that the sea level rise is going to be continuing, fast or slower, but it's going to continue indefinitely. So it's something where you have to live with it, or deal with it, or you can't deal with it. You have to live with it. You have to see how you can try to protect coastal cities from flooding. You need to try.
Sorry, but if you're talking like, I don't know, I haven't added this up, but it sounds like 15 to 20 feet of sea level rise we're talking about. And I don't know
where. It's actually at the peak of the last ice age, the sea levels were lower about they were lower about 80 meters or something like that. Because there was so much water embedded in the ice. So if we lose all of these glaciers, it's much more than 20 feet. It's 7 meters from Greenland is multiplied by 3.3. That's about 23 feet. The 5 meters from West Antarctica is about 16.5 feet. And, the 50 meters or whatever from the East Antarctic ice sheet. I mean, we're talking about massive, amounts of sea level rise. So
you can't then, Peter, you can't talk about protecting cities with, there's no way to protect anything, is there?
Well, I disagree.
If let's assume that the sea level rises, I don't know, 25 feet.
Yeah.
How far inland is it going to go? How much of North America would be underwater that isn't now?
Well, we lose lots of cities around the world, major cities. The only way to stop it is to just to slow and stop and reverse the warming. It's the only way. So we need.
The most ambitious people only still talk about hurrying up. Well, I mean, now there's more conversation because of the war about how maybe Europe could switch from, Russian gas to windmills as fast as possible or something, speed it up by a couple of or 3-4 years. That would be the most ambitious plan that anybody's talking about now, and how to send stuff over from the US and Canada to heat Germany next October. That, they're talking like that, but that's like a drop in the bucket. That's not going to affect the dynamics of what you guys are talking about now, is it?
Well, no, it's not. I'm quite pessimistic, because you can achieve in the short term, by enormous efforts, effects on global air temperatures by the various methods of trying to do away with carbon dioxide from the atmosphere and methane. by applying a sort of enormous sort of mega efforts, you can deal with, or you can reduce the amount of warming of the atmosphere. But the trouble is that the rise of sea level now is determined by melting of the major ice sheets of Greenland and Antarctica, and they have a kind of momentum, a flywheel effect going on, that even if you can sort of reduce the rate of warming of air temperature, the deep down ice, hundreds of meters thick, that you have in Antarctica and Greenland, once it gets going, and it is going to keep going, and we won't be able to easily see a way. I can't see a way to slow it down significantly. So we can expect to see these rates of rise probably increasing, and that's something that, again, IPCC never considered. And in fact, it was really remiss, because in its previous assessment but one, they ignored the melting of the ice sheets. They just considered the rise of the warming of the ocean, and got at extremely low values for the predicted sea level rise by the end of the century, which were, I think, criminally low, because they knew what was going on, but they didn't choose to include it in their models because they couldn't see how to do it. But instead of
sorry, they couldn't see how to do the calculations, or they couldn't see an answer, a solution to it, and they didn't want to talk about something that they couldn't solve.
Well, that's the suspicion. So they couldn't assess how great the ice sheet melt was going to be as a contributor to sea level rise, and so the temptation was to ignore it completely, and that way then you didn't frighten the horses. But it's not was not a good idea, because you start to see the rate of rise exceeding what they predicted. And I was at a conference in China with after about 3 or 4 years ago, where they were working with these old figures from IPCC of how much sea level rise there will be, and we're using completely out-of-date figures for estimating quite small sea level rises in Shanghai. And Shanghai is a network of sea level canals, and the people responsible for Shanghai were not doing anything, because they were basing themselves on IPCC's last assessment. So IPCC has committed a major crime against humanity there. But the problem is that it's always been an underestimate, and that's making it dangerous now. I mean, it's especially with this, what will be the sea level rise by the end of this century, because it's still, IPCC is still giving out figures of about 1 meter. But I think all the glaciologists who've looked at the ice processes, the breakup of ice shelves, the melting of ice sheets, get much greater figures. There was a friend, really a friend of mine that I miss a lot, called Connie Stephan, who was a glaciologist, a Swiss glaciologist, who was working on the Greenland ice sheet from a base which he built himself. And he was convinced that there would be about 4 meters of sea level rise by the end of this century. And that was then regarded as insane, lunatic alarmism. This was about 4 or 5 years ago. But he was convinced that the processes going on would lead to that, and was busy collecting data on that when, unfortunately, he died in an accident on the ice sheet. But he was convinced that it's crazy, just as it was crazy to use the old figures of IPCC, of which only foresaw a tens of centimeters in a century, it's now equally crazy to use their latest figures, which only foresee, say, a meter by the end of the century.
Or even half a meter. I mean, Peter, what would your best guess be for 2100? My best guess is 7 meters by 2070. That's what I've been saying, 7 by 2070. I did videos about 2 or 3 years ago on it, and people ask me to update it from time to time. It's just there's so many mechanisms that can speed up the ice melt. I mean, I'm probably out to lunch. People still think I'm out to lunch on that. So how about you? What would you say by 2100? I mean, James Hansen has been saying for years, 5 meters by 2100. And he's just looking at the doubling rate of melt from the Greenland and Antarctica. So, if you look back, with the doubling period of about 7 to 10 years, or even 5, I think he's modeled 5 years doubling period and 10 years. So in other words, in every 5 years or whatever the doubling period is, every period you get an increased doubling in the rate of ice melt. So, and that's been held for, I say it's about 7 years. And for the last 21 years, it's held, so if it continues to hold for the next 21 or 50 years or whatever, then back of an envelope calculation allows you to easily get 7 meters by 2070, for example. So I don't know. Do you want to hazard a guess, Peter, for 2100?
Yes, I conservatively guess 5 meters.
5 meters, yeah. I think that's, yeah.
Well, I was out up on the Greenland ice sheet last November. In fact, I should be doing some work on the ice sheet in Iceland next week, but unfortunately, I'm not suffered a problem with my leg. But so my wife is going. But what we were doing was collect, not only measuring the retreat of the ice sheet, but looking at the change in albedo of the surface. And that's one of the contributors to the acceleration, is the fact that the ice is getting blacker. With all the brush fires that are occurring, spreading soot all over the ice sheet, the ice sheet is getting darker because the ice is melting, turning into water, and that's draining away to sea. But the dirt stays behind. So the surface of the ice sheet gets dirtier and dirtier, darker and darker. And as it gets darker, you get more and more absorption of radiation. So that's another process which is occurring and speeding up the loss of ice. It's like everything in climate change is an accelerating process. There's always, all feedback seem to be positive, and all the processes are accelerating. So if this one...
Now you said, Paul said that there's a doubling every 5 years or so.
Say 7 years.
That means that it's an exponential curve, isn't it?
Yes, exactly.
Yeah.
And the other thing is Peter, the other point, could you tilt your computer monitor down a little bit, Peter? Because we're losing we're losing your mouse sometimes when you're speaking, just so that your face is centered in the image a bit better. But Peter, also, as we lose the surface of the ice through melt, it's not just the ash from present fires, right? If there was a volcano 20 years ago or 50 years ago that deposited a lot of ash and debris on the ice, then that ice is embedded in the ice layer and is below the ground. So as we get melt off the surface and a lowering, the surface layers melt off, we also can expose that ice down below, which is not the case if the ice sheet is growing. Like if the amount of snowfall each year, which can then over 50 years or whatever turn into firn, and then solid ice, deep down in the ice sheet, if it's ablating at the surface each year, that exceeds the replenishment. And up to now, recently, that the replenishment always increased. So the top of the glacier would maintain, its level more or less. But now the melt is becoming so large that we're burning through these layers, and that can expose contaminants that are in the ice. I mean, think of what the snow looks like in our spring, right? Even, you get the dirt and debris, and, the snow piles that are left right now, we do have them left in Ottawa. They're probably all gone for you in Toronto. Man, they've been gone a while, but they're like filthy black and dark, right? So it's the same sort of thing. And it's raining right now in Ottawa. We're getting 30 millimeters of rain or so. And you can notice that, it takes a long time for the snow to melt when there's just warm air temperatures. But as soon as you get a rain event on the snow and ice, it just cuts into it and completely annihilates it, very, very quickly, much faster than if it's just melting from air temperatures above zero. So this is a big, huge concern. When we start getting more and more rain events in the Arctic, then that ice just gets cut to shreds. Look at the big flooding a few years ago in Calgary. So we had a rain on snow event in Banff in the Rocky Mountains, and then it just caused so much melt of the snow and ice that it poured into the river systems, and it took out cities like Canmore, and then a few days later it was right into downtown Calgary. So, rain on snow is clearly it's a very powerful way to melt large quantities of ice in very short periods of time. And this is what these atmospheric river events in the Arctic and Antarctic can do. And they're just not accounted for in any of the models.
I hate to go back to bad news, but you really bothered me, Peter, when you said there's just no answer. And I'm thinking quickly, what about, there are certain things that will take a long time, if any. I mean, if we just cut out fossil fuels today, that in itself is not enough, obviously, or at least it's been obvious to me for a while. But there's nothing that would be instantaneous except for maybe something like spraying sulfides or something into the stratosphere, or something, this putting up a big umbrella over the earth. That would do it quickly, wouldn't it? But would it, even something like that, be sufficient to interrupt the process that you've already described, where you say once it gets going, you can't stop it? That's what I'm thinking. Let's look for solutions. Is there anything, if we did it something instantaneously, like a big umbrella over the earth?
Right. We'll just get Elon Musk to put huge cylindrical rolls of mylar, very, very thin material, coated, aluminized to make it reflective. And we'll just put it in his latest rockets, and we'll send it up into space, and we'll block, a small fraction of 1% of sunlight. And then that will eventually stabilize the loss of ice and prevent this massive sea level rise. So there you go. Do you agree, Peter, or do you think that the ice would still, the lag in the ice, the built-in climate changes would decimate? I don't think it would decimate Greenland and Antarctica. I don't think we could do much for the sea ice unless we did something right away. So anyway, when Peter says nothing can be done, that's assuming that we don't do some massive project that reduces the amount of sunlight on the Earth.
Yeah, even massive projects are going to be difficult to see how they could work. I mean, it's easy to see how we can do something dire and negative rapidly. Because it's meant to sort of saying, well, what can we do rapidly? Well, I mean, we could have a methane outbreak from the Arctic Ocean seafloor and get about a 1 or 2 degree warming instantly or within a very short time. So we can inadvertently do something rapidly, but it's in the wrong direction. And what we want to do is to do something rapidly that's in the right direction. And in the right direction, it's persuading large ice sheets to stop breaking up, to stop melting. And you can only persuade a large ice sheet to stop melting if you really warm it up. And we're
really cool it down, you mean?
Sorry, really cool it down, yeah.
Yeah.
And we're not doing that because we're warming everything up, and cooling down a huge continental-sized ice sheet is something which you can only do as part of an overall strategy of cooling the planet completely. And
exactly.
you can try and do that.
So what about his notion of putting Mylar things up in space? Do you think something? I don't like that kind of thing.
Well, Meta, that's my. Let me just sort of enlarge. Okay, we're talking about the three-legged bar stool I've been talking about for ages. We have to slash fossil fuel emissions. That's one. The second one is we need carbon removal from the atmosphere. Carbon dioxide, methane, which just hit 1910 parts per billion, by the way, a record. And nitrous oxide. We need to remove those things to remove the heating from the greenhouse gas effect. But we don't have time to do that. That's going to take time to do all of that, I should say. So we need to deploy solar radiation management. Now, there's a lot of ideas that we've talked about. Stephen Salter's the idea is to make clouds brighter, marine clouds brighter, because it cools what's underneath them, whether it be the ocean or the Arctic or Antarctica, if you could get them there. There's the idea of deploying mirrors on the surface of the Earth to reflect a lot of the sun to reduce the heating. You can, my sort of, I'm real, enthusiast of what Musk is doing with, his engineering and technical advances, although he called compared Trudeau to Hitler, Canada's leader, recently. He says things. He looks like he bought a 10% stake in Twitter. I mean, there's lots of controversies with the man, but his engineering and his teams are doing amazing things in the car industry and the space industry, like his breakthrough stuff he's doing. So, when I think, deploying mirrors on the surface of the Earth is a lot more problematic from the logistics and just putting some big huge thing up in space, because his launch, he's chopped the price of launch capability, the cost of launch, getting a pound or a kilogram up to orbit by a factor of 10 or 20 or 30. Okay, the idea we could generate huge amounts. So there's all of these different sort of things, but the basic physics is the Earth is getting the albedo's dropping of the polar regions, as Peter said, right? We've measured this from space in the Arctic. The reflectivity of the Arctic used to be 52% 3 or 4 decades ago. And 5 years ago, it was measured to be 48%. So that's a 4%, the reflectivity dropping. The Earth is darker, it's absorbing more solar radiation. This is one of the huge feedbacks, right? Why the Arctic is warming 4 or 5 times faster than the rest of the planet, because it's getting a lot darker physically with the loss of the ice and snow cover, et cetera. So it's basic. It's pretty clear, where we're heading. And
wait a minute, Paul, you've mentioned about 3 different things. One of which I had never really heard about before: mirrors on the surface of the Earth. And I'd heard about this, putting tinfoil up in the stratosphere or above. I'd heard of a few things that, certainly the cloud brightening, which I'm all, I'm gung ho on that. I don't know, Peter, if you had to choose the most promising thing, and it doesn't sound like you think anything's going to work, but I think Paul is more optimistic in a sense than you are. And I don't
Peter's so negative, isn't he? Nothing is going to work.
But I have to be influenced by the worst, most pessimistic messages that I hear. That's the way I'm built. So, Peter, which would you pick?
I think the most promising method in terms of cost and speed of action is the one that I don't personally like, and most people don't like, which is the injecting aerosols or powders into the stratosphere, because the calculated how much it would cost to inject enough aerosol to bring down the temperature, and it is much cheaper than anything, certainly than marine cloud brightening and anything else. The trouble is, it's for other reasons. People think it's a bad thing because you're sort of helpless before nature doing its thing. That if you put a huge input of powder into the stratosphere, then you have to wait while it gradually falls out. And
will it eventually fall out?
Well, yes, it probably will, but it will take months. And then
if that's all is just months, then I'll go for it. I was afraid you'd say it'll stay there forever, or that it might be 50 years, and then we'd be helpless. But think?
Well, it's the main reason why people don't like it, is that it does have unpredictable climate effects. I mean, you're putting it all over the planet, because you put it into the stratosphere, it spreads out over the whole planet, and it will have some effect on, the monsoon or something like that. We don't know what effect it will have.
Although, Peter, it does happen naturally with very large volcanoes going off. So, I think maybe 10 years ago, I called this method the anthropogenic Arctic volcano, right? We mean to sort of like a volcano going off, very powerful. If it injects the sulfur dioxide and the air, ash and stuff into the stratosphere, then, as Peter said, it can take months for gravity to pull it down from the stratosphere. And then when it hits the troposphere, it's removed in a matter of weeks because of rain, right? Mostly, the rainfall, it traps, the particles get embedded in the raindrops, and then they drop to Earth and they're taken out of the atmosphere. I mean, it's after a big rainfall, it's just the atmosphere is beautifully clear, right? You can see for miles and miles because many of the particles are being removed. But in the stratosphere, you don't have the rain. It requires gravity. So if the particles are very small, it can take them months to settle down to the troposphere and then come out. But if the particles are large and they're in the stratosphere, then the gravity pulls them down. They drop down.
I heard somebody say that they would worry about the effect on agriculture, because if you're blocking the sun, then your plants are not going to grow.
Yeah.
Your crops
it's just a small, tiny fraction of light you're blocking. It shouldn't do anything to agriculture.
Really?
Really, yeah. And as far as affecting the monsoons, I mean, look, it's always the pros and cons, right? We're doing nothing, and we're reaching. We're only just like 1.2 above pre-industrial or whatever. Above what they call pre-industrial, which is sort of 1850 to 1900 average temperature. And look at all the havoc that is breaking out. And what's not in any of these climate models or anything is when you get somebody like Putin invading the Ukraine. So all of that carbon that's embedded in the production of war materials like tanks, aircraft, etc., then it has to be moved using all these fossil fuels to move to a country, and then it destroys the opposition's carbon-intensive military units, etc. And then all of the buildings and cities that are destroyed. I think of the carbon to rebuild all of those, and this is just one country. If a world war was to break out, and there are many countries like this, then forget it. I mean, how can we can't even, if we can't sit down and talk and make efforts to, make actually strong action to stop climate change now, when we're in general peacetime among most countries, wait until there's global food shortages and geopolitical conflict. I mean, we're talking in a totally different ballgame. Now, I'm not being optimistic or pessimistic. I just try to I try to compartmentalize myself, separate myself from this stuff, and just look at the logical progression of what can happen, events that can happen. And
Peter, would you go with what he's proposing? I mean, would I
go with the sulfur in the atmosphere? Oh yeah, I would have done it 10 years ago.
You would have done it. Well, okay, but I'm not sure Peter would. Peter's still wanting more evidence or something. I don't know.
Okay. Well, you don't have to use sulfur. You can use calcium. You can use calcium, different materials. You don't have to use. You can use. Salter is using. Stephen Salter is using seawater injected through nozzles to put these salt crystals. This is in the lower atmosphere, but you can use things, volcanoes go off all the time. There's big events like Pinatubo where they lower the global climate by 0.5 degree or 1 degree over the space of 5 years. Right? They go off, and the monsoon's failing and becoming erratic right now. The thing is, you have to look at the risks of doing nothing or deploying some sort of technology. So, it's
that's true.
But I would have been opposed to aerosols in the stratosphere in the past. I mean, that's partly because I was very, or I still am, very keen on marine cloud brightening, because I know Stephen Salter pretty well, and I think that's a very, very promising technique, and it's scandalous that it hasn't been funded on a large scale. But it's still, and it's also steerable, that you can if you do something inadvertent to the climate that's bad, you simply stop pumping the water up, and it immediately stops. Whereas if with a load of sulfate aerosol, you have to wait till it goes. But so I'm keen on marine cloud brightening for those reasons. But if you're thinking about cost, now that proper estimates are being made of the total cost of doing things, then aerosols from aircraft, deployed from aircraft, turn out to be by a large amount the cheapest way of doing it. You simply have aircraft constantly just taking off, dumping the stuff at a great height. This
is the either the sulfur or the calcium that
exactly.
Yeah, okay.
But
you can do it from a plane. You don't. I'd heard somebody say you put up a long pipe and just pump the stuff up there, but no, you could do it by exhausts from airplanes, huh?
Yes, just dumping it from an aircraft is
put it in the aircraft fuel, but you need an aircraft that would fly higher than most commercial aircraft fly. But I'm not sure if that's true. That's what I've heard. But there's a billionaire, a new billionaire, he's 30-year-old. I don't remember his name, I'm sorry, but he's made all his money on cryptocurrency. He's very concerned about the environment and climate change. And he actually he gives away vast amounts of money to different things. Like, he has no interest in the money himself in buying fancy houses and yachts. So he gives it away to people. And I'm going to try to contact him and put him in touch with Stephen Salter. And, a billionaire could provide enough money to do these things, but then he'd probably be in jail, for tampering with the climate or something. But our world is quite crazy right now. I mean, you mentioned Shanghai. Okay. Well, guess what they're doing in Shanghai? Okay. So they've got the government, people have been in hard lockdown for 17 days, not able to leave their houses. They order their food online. Why? Because of the latest COVID variant. They did it. They tested the entire population of 26 million or something over the space of 3 or 4 days, using thousands of military troops and health people and police. They must have gone to each house and taken samples and tested people. There hasn't been one fatality. Okay, but this is what they've done, right? They shut down an entire city. They're costing the economy in their billions of dollars, but they used this method 2 years ago at the beginning of the outbreak, but the virus has been mutating to all these different forms, and they're still doing 19 days. So I just say, humans are not so smart.
Yeah, I mean, it's crazy. Like, why when we know how we can offset global warming by removing CO2 from the atmosphere, or doing this work with aerosols, the total cost is huge, obviously, but it's not as huge as the fortunes of some of the richest people on Earth who have
Right.
such huge fortunes that, as Paul says, they don't know what to spend it on. So they could simply a single millionaire. It's not even a national government. A single zillionaire could sponsor. Brightening. They could sponsor enough change to actually prevent warming or slow it down significantly.
Exactly.
Is that going to be enough? Would the cloud brightening or the spraying of aerosols in the stratosphere, would either one of them be fast enough to actually stop whatever this process is that's got started, where the ice is melting in Antarctica and Greenland and so on? And you said it's irreversible. Is it really? If we did something really fast, could it be done? Number two, is it possible that maybe we could get one of these billionaires, like the one you just mentioned, you don't even know his name, who would fund it and we could go around and do it secretly? I mean, if somebody actually could figure out how to do it, don't tell anybody, just do it.
Right.
Now,
Well, you've just announced to the world it's secret, though, Meta. So we should have not recorded this part. But anyway, go ahead, Peter.
Well, it just reminds me of one of the loony theories that's been going around, pestering honest scientists like us, which is that the contrails of aircraft are secretly being used to cool the climate by a group of people who believe that, and they turn up at conferences and show photographs of contrails.
Right. So we want to actually do this, right? So
it was a fraud because they were saying it's the CIA is doing this secretly for the good of the world and not tell anyone. And you sort of think, well, could the CIA ever do anything secretly for the good of the world? It's impossible.
I'm really serious about that, because I'm preoccupied with the problems of democracy now. And honestly, I think the threat of the failures of our democratic institutions, that those failures are so bad that that's what's going to kill us. In other words, we have the answers, but we can't mobilize the political will to do any of the things that we know how to do. Therefore, I'm serious. If there's somebody who knows how to fix it, don't tell anybody, just do it. And can we, because you cannot, at this point, given the kind of structures that we have, like the UN, the veto and the Security Council, that kind of thing, those are blockages that they're lethal. That's what's going to kill us, that we can't.
Yeah, I agree, Meta. I'm all for that. I mean, I just want to give you a Canadian example of how crazy like we think that the Trudeau, the Liberal Party in Canada recently had an agreement with the NDP to sort of join together so that power is maintained through to 2025 and they can get policy done and so on. So on Monday of this week, the Liberal government released the emissions reduction plan, which looks at sector by sector reductions of fossil fuel usage. It's very much along the lines of the Working Group 2-3 report, which just came out, looking at sector by sector mitigation, okay? And they say that they're serious on climate change and they put a big chunk of money towards it, et cetera. Then just yesterday, which is, so that's 2 days later than when the plan came out, there was a big announcement that they okayed a new oil drilling project, which will come online in 2028 off of Newfoundland and provide lots of jobs and stuff. And they say, oh yeah, we can do this and still stick to our climate plan. And then you read the article and they said that when you burn a barrel of oil from, they start talking about clean oil, and you can burn this clean oil and not produce as many emissions as you dirty oil. Like this is insane. This is all insane. And yet this is a relatively progressive government that is doing that. The governments just do not get it. In fact, Canada's environment minister now is a very, very, for his whole life, he's been a very green candidate. He's done great things. He gets into government and he's the one who approved this new oil drilling project off of Newfoundland and then tries to justify it. So what happens is these people get in government and they get inundated with lobbyists and lobbyists and lobbyists. 97% of the lobbyists are with companies trying to get them to do things that are harmful to the planet, and then they go and do it. So it's like it's just mind-boggling. So in the report, the report says that even we need to shutter existing power plants that are operating on coal and oil, etc. Not let them live out their lifetime and then mothball them, and certainly not build new plants. And we're not like, but there is some hope in the report. 18 countries have cut their emissions significantly for longer than a decade. The 18.
Hey, that's good, but now we know that that's not enough. So
what about the rest of the countries?
Yeah, Peter, tell me, do you think that if we actually were able to get one of these of your pet solutions effected within a year, it would change the melting of the ice, it would stop it, this worst threat that you've been talking about?
Well, you could have it would, if you do it properly, you could have a measurable impact. I mean, there's techniques for measuring how much impact you're having. Like Sulfur has a way of looking at how many clouds are being produced and what difference does it make. And so we could assess what's happening. But I agree that in general, it's like with Paul, that our democratic institutions are simply not working. And the case, I guess our equivalent of Trudeau is Boris Johnson, who's even worse. So he's the ultimate buffoon type liar. And he as co-chairman of the IPCC of the COP26 meeting in Glasgow, where I was there, and the first thing he did was disappear in a government plane to have lunch in London with a zillionaire newspaper owner who's in favour of fossil fuels. So that was pretty bad. But he was also said, well, we must not, this is our last chance. It's what politicians always say, it's our last chance, then they do more things. But the last chance, and it must involve not doing any more addition to the infrastructure of fossil fuels. We must sort of close down coal and oil, and sounded wonderful when he was saying it, because he went to Eton, and so he had an upper class Twit accent. But when within a month, Britain was then developing a new whole oil situation in Scotland and Shetland that they just discovered. They're cutting a huge tunnel under northern England for coal, and they put a load of money into another oil development in Madagascar. So we're simply going right ahead with all the bad things that make the climate worse, whilst pretending that we're doing something.
Meta, the mirrors on Earth. It's look up, Google the acronym MEER, and it's Yi Tao at Harvard. I believe he's at Harvard. Is doing all of the work, and there were a lot of he gave a presentations in Glasgow at the COP.
Okay, I'll do that for sure.
Yeah.
Okay, thank you guys. Appreciate it.
Thanks, Meta, and thanks, Peter. It's always, these are my favorite discussions with you of anybody else, of all people.
Me too. I love you both. Thanks, guys. See you next time. Bye.
Bye.
Project Save the World produces one of these shows 3 days a week, and sometimes more. This is episode number 434. You can watch these or listen to them as audio podcasts on our website, tosavetheworld.ca. Eventually, we even post the transcripts there. And when you get to that website, look around, because we have conversations going on there about 6 global issues and potential reforms in governance, economics, and civil society. To find a particular talk show, enter its title or episode number in the search bar, or the name of one of the guest speakers. After you've watched or listened, scroll down and share your own ideas about the show with the other viewers. This is a place for dialogue, so please join in. I'll see you there.